Hello and welcome to everyone to this Friday talks of the ANH. Today, we are happy to have the Colombian Geological Service with our workshop number 14. Today, we'll have the Colombia Caribbean Play for Fairways today on May 20th of 2022. So firstly, previous to give the stage to Victor Ramirez, I would like to announce the next talk of next Friday, that being to the May 27th, the ANH workshop number 15, will have an introduction and the seismic interpretation in areas reserved by the ANH into the recently acquired seismic survey into the Sinú San Jacinto North area that is called Repelón. We'll have as well a brief presentation by the UPTC into the Middle Magdalena for Lizama formation. We'll have as well the Putumayo Basin, Las Águilas by the ANH. We will be presenting as well details for financial help to postgraduate and last year students with MinCiencias, and the free data for research in frontier areas with the Geological Service. Next talks. So in June 3rd, we'll have the MinCiencias research group with the geological habitat prospectivity and social environmental and economic sustainability of wet gas into Colombia as energy transition fuel. Into June 10th, we'll have recent discoveries in the Colombia, Caribbean and Gulf of Mexico, analogies and prospectivity. In June 17th, we'll have the prospectivity of the Cenozoic units from the Upper Magdalena Valley. And into June 24th, we'll have seismic interpretations in areas reserved by the ANH, the seismic survey acquired in 2018, Nueva Granada. And we'll have as well Lower Magdalena's Pailitas, a stratigraphic well that was drilled last year by the ANH. And we have El Miedo, that was already a field that was already developed into the Llanos Basin as an opportunity. We'll be presenting as well some details for financial help to postgraduate last year students from the undergrad. And we'll have all the data free for research into frontier areas from the Geological Service. This is a quick reminder of the areas that into these talks during this year we have been offered to be nominated. So as you can see, we have areas at the north and into the Lower Magdalena and to the Sinú San Jacinto with gas and condensate. As well, we have promoted areas with light oil, medium oil, and heavy oil, and the areas of the CPOs that are at the southwestern part of the Llanos Basin. So today we have as a speaker Victor Ramirez, that he's a geologist from the National University of Colombia, graduated in 1993. He's got a specialization in economic geology from the ITC into the Netherlands, graduated in 1996. He's got as well a Master in Science in Geology from the University of Alabama in 2007. He worked as exploration geologist with Ecopetrol from 1997 to 20 as leader of offshore projects and several publications of Caribbean petroleum systems. From 2020 to date, he's worked as an independent consultant and senior advisor for the DTH from the Geological Service. And he has been as well former president of the ACGP, the Asociación Colombiana de Geólogos y Geofísicos del Petróleo, and the APG, Latin America region, and member of the APG Advisory Council from 2021 to 2023. And he's representing the Latin America region. So I would like to give the stage to Victor Ramirez for the presentation about the Caribbean Play Fairways. Thank you.
Okay, thank you, Daniel. Thank you, ANH, for opening this space for me to present this work done on behalf of the Colombian Geological Survey, the Dirección Técnica of Hidrocarburos. I will give you an overview of the project we did in last year, 2021, where we put together all the information we have available in the Caribbean in order to apply plate-based exploration to propose plate concepts in the Caribbean and further additional ideas for exploring these interesting areas. I'm going to turn off my camera because I'm going to use another screen, and I'm going to start sharing my screen. Can you confirm that when you are seeing my screen, Daniel, please. Are you already seeing my screen?
Yes, yes, yes.
Okay. Okay, again, a brief title of this presentation is Plate Concepts Applied to the Colombian Caribbean Basin. This is what this, as I mentioned, this was a project executed in the second semester of last year by the Dirección Técnica of Hidrocarburos or the Colombia Geological Survey for ANH. The technical team we put together was an experienced team of senior geologists and interpreters that managed to gather all the information and putting together the ideas I'm going to show you in a minute. Here is my email in the case you have for the question. We work along with Fabricio Convita, Andres Lozano, Leonardo Moreno, Cesar Mora as petroleum system expert for the Caribbean, Juan Carlos Ramón as technical director, and we had a very important input of Lady Ramirez as GIS expert and Gabriel Santana as expert on editing and drawing for the putting together the project, which at the end of the project was put together as an atlas format. The format you see here in the screen is the same format you will have when you go there into the NH and have access to the document. And we want to give a special acknowledgement to NH, Maria Rosa Cerón, Liliana Zuleta, Miguel de Armas, for all the support in providing the information, and the EPIS personnel for giving access to new data, complementary data for the project, and Virgilio Maris and Responsabilidad from the Geological Survey for all the support. I'm giving you a short overview of the plate concept that have been applied in the past in the northern Colombia. Of course, I'm talking about the specific. I'm focusing on the offshore part of the Caribbean. Plate concepts have been published and exposed in some occasions in the past. The first one here in the left, there's some simplified concepts of plays associated to a stratigraphic target in the Guajira area that was published by myself in my master thesis from an internal work that I did in Ecopetrol, and these plays are associated to the stratigraphic level where we thought that we have some potential. Of course, the information was limited to the particular basin. We didn't have access at the time of to the quality of information we have today. And shortly thereafter, Bence in 2008, she published this in her master thesis, proposed this place associated to the tectonic geographic location. Here we're already thinking about differentiating the shallow water place from the deep water place, and recognizing this very interesting feature of the sub-Caribbean default belt that represents the boundary between the South American plate and the Caribbean plate, and already thinking what older sequences, older than the tertiary, I mean, Mesozoic sequences, can be present in the system. Further on, in 2015, in the Memoir 108 from AAPG, Ardila and Diaz published this very interesting proposal of regional plays based on regional observations, their internal work they did before for the ANH and Geological Survey, where they suggested the presence of these features, both structural and stratigraphic, and mainly related to the areas close to the coast. Ecopetrol in 2016 presented these two interested sections, one in the north in the Guajira area, one in the south in the Sinú offshore area, where there is here we have a depiction of the features related to the tectonic environment, again related to the convergence between the South American plate and the Caribbean plate. And very interestingly, Ecopetrol is already proposing the presence of Mesozoic rock with the subrock potential present in the deeper part of the basin. And here, of course, with these rocks involved there, we have to think about thermogenic processes and oil-prone features. In the south, in the Sinú area, the environment seems to be more related to a biogenic province, and of course has been tested at this time by the discovery of at the time for the Kronos well in the south, and the stratigraphic plate related to the deeper part of the basin and a structural plate or combined plate in the footwall of the South Caribbean default belt. More recently, in 2020, ANH contracted 3 works with universities to cover the whole Caribbean area. One work was performed by Universidad Nacional in 2020. This is the area that they cover in this project. At this time, they managed to describe place based on the trap geometry. Here is a simplified depiction of what they have identified. I think was the level of 15 places that they identify, especially related to the trap geometry. Very interestingly, in a regional distribution related to the deeper portion of the area, or what we call now the Columbia Basin. At the same time, a work performed by Universidad de Caldas in 2020 was focused in the Sinú offshore area. They also proposed 5 or 6 places described based on regional interpretation. Here is a regional distribution they propose. And in the northern, in the Guajira onshore and offshore area, Universidad de Pamplona also managed to pull together a regional interpretation, proposing these 6 play types in the area. All of these works have been based on regional interpretation, but as you might recognize, these were 3 different independent projects which didn't produce results in the same fashion. The description of the place were not necessarily in the same technical concepts, so it was difficult to put together in a whole overview. And this is what we are going to show today. In our work in 2021, we put together all these, the former projects that I just mentioned, the projects from the universities, and we put together all the information available that we could have access from the EPIs and from the published information, from the published literature. The regional interpretation, we focus on this area. These are expression of the bathymetry in the Caribbean was put together for our project. Here we identify very nicely in the bathymetry the tectonic regional features like the Hess Escarpment, the Embera Ridge, where one of the ODP projects is located, the 1991, the Beata Ridge, where the DSDP 151 and 53 are located, the Columbia Basin, the deeper portion of the area, the Magdalena Fan, it's nice expression here in the bathymetry, the southern part of the South Caribbean default belt, which has a trend rather like in south-north, and in the Guajira area, the South Caribbean default belt that has an expression a little bit more west to east. This is an expression on the geometry and geomorphology of the basin. And in this yellowish contour, we had the study area that was recommended by the Ministry of Affairs in order to avoid getting too close to this area that is in discussion with Nicaragua. The database we had access to was the 3 projects we just mentioned from the universities. When we put this together in a petrol project that is already suitable for interpretation, we cover an area of more than 250,000 square kilometers in extension. In this area, we had access to 110,000 kilometers of 2D seismic, the level of 6,000 square kilometers of 3D seismic, and 66 wells, both in the coastal area and in the offshore area. With these wells, we managed to have the information from time to depth and calibrate all the interpretation. And we put together the projects that were performed before for the universities in a single platform, and the objective was to have a a single approach, an integral approach for all the information available. Here I will show you some examples. The project is available, of course, but I will have to compromise a little bit in time due to the time, but I will show you some of the results. We prepare regional interpretations and mapping for entitlement depth for basement, for the Cretaceous sequence, for the Oligocene, we think it's the late Oligocene, the late Miocene, and the sea bottom, of course, associated to the topography. And this is an example of the basement map that we prepare for the first time regionally, integrating the Cuenca Colombia, the Sinú offshore, and the Guajira offshore in one single representation, one single map. It's very interesting, the trend we see, the trend close to west to east, this trend that is a deeper portion of the basin, something like authors like Ecopetrol called the Iguana Rift. And recently, maybe some of you saw ION presentation a couple of weeks ago, where they claimed that very nicely related to this area, to this deeper portion, is an area where they claim that the cross is in a thinner position, less than 3 or 4 kilometers of thickness, which is very interesting because it should explain why what has this depot center located right there. And another example is the late Miocene structural map. We have the same trend. We have the deeper area in the central portion of the Columbia Basin. And again, the representation including the Sinú area and the Guajira offshore area. We also prepare 6 regional interpreted chronostratigraphic charts. Here is the map where we show where the chronostratigraphic charts are located. The type we have for these charts are the DSDP and ODP projects. Here is we are representing the chart in the center. In this particular case, we stretched a bit the horizontal scale in order to be able to represent properly the Magdalena Far area. These are the area in yellow, the yellow portion from middle to upper Miocene and Pliocene, the representation of the presence of the Magdalena Fan. The area where it should be, it's not directly observed there, but there, the proximate area where the South Caribbean, the Fort Bell should be present, and the well control we have here in the near shore area. And in the offshore area, further offshore, we have the DSDP 151, which very interestingly drilled down to the Cretaceous, including Santonian and Campanian units, which is very interesting because these units might represent potential source rock, which I will talk further on. We are now reviewing in detail this information because it seems that with more recent is a couple of months ago evaluation, the hiatus we represented here last year might not be present. It might be, and this might be a continuous sedimentation. Of course, I will show you this is in a higher position in the deeper portion of the basin, and this might be represented here in time, but in depth, they might be a condensed sequence. We also prepare 6 regional cross-sections where we want to reflect the structural concepts. Here is again, which presented here again, a cross-section from the area close to the Beata and Embera ridges, this area that has these intruding features or paleogeographic features in the deeper portion of the basin. Here we are in the level of 4,000 meters of water depth. The wedge that we have of sediments coming from there up to the convergence area where we have the South Caribbean, the Fort Plate. This wedge expression can represent the accommodation space we have for these sedimentary sequences. And we represent here that the Cretaceous might be present in the deeper portion of the basin. We don't know, we have no records of Paleocene, but we believe that we have Cretaceous, partially a Paleogene sequence, maybe mainly Oligocene and partially Oligocene and partially Eocene. And on top of this bluish marker, we have mainly Miocene and Pliocene units. Here is the area close to the Arasa well. Here, the well is here represented, where internally or in the inner part behind of the South Caribbean default belt, we might have the influence of strike slip or wrenching tectonics related to this area or Santa Marta, Bucaramanga, and Anoka fault systems. And we have 6 sections represented here is one of the examples. Now we'll walk you through the play concepts that we have identified in the Caribbean offshore Colombia. We identify 16 play concepts, and I'm going to show you some of them, I think 11 of them, but all of them are more detailed, and we have more documentation in the report. We are not trying to say exactly that we have a hierarchical order here in the representation, but some of them, of course, are more important or have been already proven. One, with a very straightforward definition, is sandstone on basement high. This is one of the most important places we identify in the area. These places are related to the development or cluster reservoir around or overlapping regional basement highs, including units from late Oligocene to early Eocene, early Miocene, displayed according to the, as we represented here in the geographic distribution, is present in Guajira Basin, associated with these paleo highs or paleo geographical features. This play has been proven in the Chuchupa field. Chuchupa field is a field discovered in 1973 by Texaco at the time. It has a original gas in place of more than 5 trillion cubic feet of gas. And here we have 2 representations, one line west to east, showing the depiction of the feature. We have an event, I don't know, you might see it, but we have a dimming out of the lower seismic event on top of the basement. Maybe the dimming out, or we believe the dimming out, is related to the presence of gas, and the reservoir is these sandstones on top of the basement. Another section that in an oblique direction, that from southwest to northeast, shows a high relief of the feature, and again showing how the sequence is overlapping or overlying the basement, is very close to the basement, and we see the feature of clastic sandstone developed in the area. This display, sandstone on basement high, we believe is present in the southern part of the Guajira Basin, and also, very interestingly, has been already tested or very similarly tested in the Orca discovery. Orca discovery should be in the level of 0.5 to 1 TCF, is still in evaluation by Petrobras and Ecopetrol, and has proven the presence of Oligocene reservoirs in the northern part of the Caribbean. Some other areas where we see, or we might see, the development of this feature is to the west of the campo of the Chuchupa field. We had these paleo highs related to the Chuchupa platform, maybe with a later faulting that broke the Chuchupa platform. I had in detail here, we see in detail, we might have the development of the same plate as Chuchupa. Very interestingly, in the Chuchupa field, we don't have 3D seismic, but in this area, we had 3D seismic available. So this can be studied in further detail. This is a southwest to northeast depiction of the same feature. Some amplitude anomalies are very interesting there, and this area is already covered by it's already covered by 3D seismic, and is subject to further attention. Another very important play we had identified in the Caribbean is the carbonate on basement highs. It's a similar geometrical feature at the sandstone on basement highs, and in the area, in the middle part of the Guajira area, of course, we have identified the Ballena field. The Ballena field is a discovery from 1973 and is still in production. And regionally, we have features. Of course, if we go a little bit further from our study area, we have Perla discovery with the carbonates from Upper Oligocene to Middle Miocene. Here we have the level of development of 200 meters of carbonates. If we go further west to this area, of course, out of the study area, we have the Paraíso well drill in 2016 by Noble from Nicaragua. And they discovered 550 meters of carbonates. The petroleum system didn't work properly there, but around the Caribbean, carbonates are still a feature of very of high interest. Some locations we believe that there are some basement habit development carbonates are here in this area west of Cartagena and Barranquilla, and areas near to the Urabá Basin. And of course, these carbonates are related to paleogeographic conditions associated to shallow bathymetries. Here is a depiction of the Ballena field. Here again, we see the top of the reservoir. Here we see this dimming out of the seismic response, and even a vertical feature that might represent the scale of gas. Ballena is in the level of close to 2 trillion cubic feet of gas, also discovered in 1973, and a very interesting part is part of the production area we have today, Chuchupa and Ballena. Another very interesting plate we have identified in the Caribbean is the plate associated to the fault belt structures, closer in the fault belt, or some might call this a accretionary prism, depending on the tectonic environment you accept for the area. But in geometrical terms, it's a fault belt. These are anticlinal and monoclinal structures related to the South Caribbean, the fault belt, that might involve rocks as solo as the late Oligocene up to Pleistocene. This area is this place should be identified all along the South Caribbean, the fault belt here in the offshore area, and in the Caribbean in the Guajira offshore area. Is not present here. Might be is covered, hidden, or obliterated by the Magdalena Delta, but here is the distribution we identify. Here is the expression of the play that has been already tested in Kronos, Gorgon, and Purpuradier wells. Kronos and Gorgon are wells that tested this feature. Here is the first structure, the monocline structure in front of the South Caribbean deep belt in the south. Kronos is like 40-50 kilometers to the north in the same trend. The relief in Kronos is a little bit shallow, less pronounced, but shows a really high extension of this structure. And now, as we speak, Ecopetrol and Shell are drilling Gorgon 2 that will attest, will provide additional information in this area. We have seen the level of some authors claim that this is in the level of 5 to 6 TCF. These are not official numbers, but this area is extensive. And different, in contrast with the Orca area, the thickness of the column here is higher, the extension is higher, the extension is larger, but these wells haven't been tested. Maybe Gorgon 2 should be tested and give information of the performance of the reservoir. And here is the same seismic line without the interpretation in order to show you the quality of the data. These are 2D seismic lines. Of course, the operator and NH have available the 3D seismic present in the area, which allow for further detail. If we go all the way to the north, we still see these features, even in the better seismic image here further north, even north of Orca discovery in the fault belt. We have this feature that have the merit to be tested in the future, especially because they are located on top of this deeper portion of the understorstein plate that is coming from the Caribbean, and maybe the Cretaceous could be here in a proper position to feed the features we have in the fault belt. And along, or maybe a different plate or a associated plate, we have in the fault belt, in the front of the fault belt, strike-slip structures. We identify here, like in the example of the Calasu area, the asymmetry of the South Caribbean fault belt in right and front. If you go in the first structure in the Columbia Basin, the anticlines and the closures seems to be more symmetrical. Some authors claim that this is a opposite versions of the structure. Our interpretation claim that here we have more the influence of strike-slip deformation, like in the Calasu well that was drilled some years ago. The Calasu well drilled some progressive submarine fans in the South Caribbean fault belt that, as was interpreted by Ecopetrol team last year, presented in a event with APG. And this feature is developed all along the front of the South Caribbean fault belt. This is not exactly the same distribution of the South Caribbean fault belt. This is a belt that is a little bit upfront, but has also a very interesting regional distribution. Another feature we identify as a very interesting play is the unlap against basement high. This has a very widely expression, very regional distribution, present in the Guajira and Columbia Basin. Can be partially associated with the development of sandstone of basement highs, but we identify that in some of the locations, the stratigraphic features are unlapping against the basement highs, and I will show you some examples. There has been proven successfully in the past in the Chimare and Santa Ana wells. Santa Ana tested gas here in the area overlapping. Let me show you here. This is the close to the top of the Oligocene lower Miocene unit. Is overlapping against the basement high. If you keep going up to the east, eventually this will emerge as the Los Monjes platform already in Venezuela area. These wells, the Santa Ana well in particular, was tested in 20 feet of sands, tested in some million cubic feet of gas, very interestingly, but the thickness of the sequence that might have the same petrophysical properties is thicker. So we might be here in front of the undeveloped discovery in the level of 1 TCF. And another very interesting information that needs to be kept in mind is the Santa Ana and Chimare reported during the drilling heavy oil residues. They claim that there are evidences of heavy oil. It's unusual that in the Guajira area and the Caribbean province that has been supposed to be mainly a gas province, we have heavy oil remnants, heavy oil residues. But it's something to have to keep in mind, especially because this area can be, or is the area that's in front of the Venezuela basin here, Venezuela area, Venezuela Gulf, where we have in the south the Perla discovery. So this presence of heavy oil could be of interest. If we go into the Columbia Basin, we have these two locations of these seismic lines. We see this expression of depot centers, might interpret this as hemigravens, where Paleogene or Cretaceous sequence can be preserved, and the unlapping of these units against the basement highs or the paleotopography can represent very interesting features here in the northeastern part of the basin, close to the Beata Ridge, and here in the southwest part, close to the very striking high relief feature as the Hess Escarpment. So this sequence, if you follow one of these seismic events, is unlapping, eventually is unlapping against the basement highs. Also, another play we have identified in the basin is the Mayo-Pliocene channel complexes that are more related to the close to the near shore areas. These are classic deposit from near shore Magdalena Fan here in the center, of course, this of course, it should be related to the Magdalena fan. But we see some other features, especially in the Guajira, that are not necessarily related to the Magdalena or Paleo Magdalena River. And this is the distribution which we propose for these features. This has been tested in the Cartagena and Mapale area. These wells, like Cartagena, tested some million cubic feet of gas per day in 1979 and 1980. Further on in 2012, we drilled Ecopetrol and Ekion drilled Mapale 1 well in the same system. Here in the right, we see an interpretation from the 3D seismic of the channel complex. And here in this area, Mapale 1 was drilled, and maybe Mapale was in the edge of one of the channels and didn't test the full thickness of the channel and was considered uncommercial. But the presence of gas has been already tested there. It's a gas province, it's a gas accumulation already tested, and maybe pending on further work when gas market conditions allow for it. In the Guajira, as I mentioned before, we have this feature. Here, you look to the map, we are right west of Cabo de la Vela area, the Carpintero High. We have these very interesting amplitude anomalies identified here in 2D seismic and already published here by Ecopetrol in 3D seismic, where we have these channel complexes coming out from the area of Cabo de la Vela right here to the west. By the paleogeographic position of this area, we believe that this can be a drainage different from Magdalena River, maybe a Paleo Rancheria River, or some rivers that were coming out from the Maracaibo area to the north, up to the north. More directly associated to the Magdalena, we have a place that we call the distal Magdalena fan, the part that is farther offshore from the Magdalena River contribution, and could be a little bit older mid to late Miocene clastic deposit, filling up the basin as far as to the escarpment. This has been supported by Javier Hidárraga works in the last years, where he studied all the contribution of the Magdalena River to the basin, and the main contributor for the basin is the Magdalena River, especially in the deeper portion of the area. If we come to the area closer to the coast, of course, as you saw, we have the closer contribution of the Magdalena, of the near shore fan of Magdalena. The features I showed you here in the Guajira, and maybe in the south, you have the contribution of the Atrato River that has a more restricted geographic distribution. But this is the area we ascribe as a big contribution of the Magdalena River. And there has been recognized, as I mentioned, by Hidárraga and Leslie and Mann that also recognized that all these amplitude anomalies in the deeper portion of the basin has to be reservoirs deposited by the Magdalena River contribution. These are amplitude anomalies that have been analyzed, studied. They have vertical features that might connect this with deeper portion of the basin with the hemigravens, where through the migration paths we might have accumulations. This has been identified also in the little bit close to the South Caribbean, the Fort Bell here in this area, in the big 3D seismic programs Esmeralda, that was shown recently by Oxy in the ice in Cartagena like 3 weeks ago. And the seismic information they presented there, which is 3D seismic, shows again these very interesting features. And for this feature, we have to keep in mind that might be fed by Mesozoic source rock in the same area. Here, pay attention to this map. This map is the distal Magdalena fan, the distribution we ascribe to the reservoir, and here the distribution we might assign to the source rock. The geographic overlapping is, of course, very interesting. We have the interpretation that Cretaceous can be in this area and could be in the locations here in the inner portion of the Guajira offshore in these particular areas, and some locations here west of the Gulf of Morrosquillo. This has been interpreted by seismic phases, by the wells here, ODP and the SDP, in this portion in the Vera Ridge and the Beata Ridge, and in this bar location by evidence, direct evidence from piston cores here in Morrosquillo, in Baja Guajira, and wells showing the presence of Cretaceous here in this area. Of course, this is very important because the Cretaceous in this part of South America may have or should have a oil-prone character as a source rock. And here is a regional depiction of the distribution of these Cretaceous. Of course, it's tied to the wells. The ODP here is somewhere here in this height. As I mentioned, the sequence there should be a condensed sequence that goes and might develop a thicker section here in the deeper portion. Here is something that was presented recently by ION and ANH. Was presented before last year and was presented few weeks ago. And this sequence here represented the upper Cretaceous units that, again, I had to make emphasis on this, in the deeper portion may have a thicker development. Here is a more very interestingly a side of our model that we showed you in a minute that has been already published by Carvajal et al. In 2020, where in this regional part, in this portion and a regional section, the Cretaceous can be present all along the deeper portion of the basin. We might have a more detailed interpretation that maybe the Cretaceous is not all the way through, but still, if we are having more, even if we have a more conservative distribution of the Cretaceous, it's still a maturity position, and the extension of the distribution is still really interesting. And of course, is located underneath the distal portion of the Magdalena contribution, which might represent a very good combination for petroleum systems, or for the petroleum system or this particular play. Another feature we had identified as a very interesting regional feature that we are not at the time in another project with the geological survey is the mud diapirism. The trapping features associated to the mud diapirs, the mud tectonics, is very interesting because it represents both the presence of high pressure in the older sequence of shale sequences, maybe from the Paleogene, with high pressure regimes, the presence of fluids, and maybe the presence of hydrocarbons, maybe attested by the presence of hydrate. Here is the distribution we interpreted. We took from a regional interpretation of the mud diapir features. And that can be both present in the column, the stratigraphic column, and some many times break through the stratigraphic column down to up to the sea bottom. Here are some examples of these features. The deformation of the sea bottom is very evident. And sometimes the mud diapir doesn't break through the sea bottom, and in some of the times they break through the sea bottom, producing these interesting mud volcanoes that can be observed in seismic and in bathymetry. And it's very common that we see this feature here, this line that is mimicking the sea bottom, as recognized by the geophysicists as the BSR, bottom simulated or simulation reflector, that reflects the presence of the free gas zone. That means that in the system, it should be present a hydrate accumulation, hydrate layer. This hydrate, of course, this is methane hydrate. Of course, could be biogenic, of course, could be thermogenic, but still, but even though shows the presence of hydrocarbons in the system. Another interesting feature we see in the regional interpretation is the Miocene and Pliocene prograding sequence that are coming from the platform. The paleo platforms in the system are prograding, sometimes are aggrading or prograding, showing this development that theoretically in the platform break might have a good development of reservoirs. And up deep and down deep by phase change, you might have a seal that will provide a very interesting stratigraphic trap that might need additional information like 3D seismic for further studies. Here is the example, is an example on the Guajira area, where in the same location, we have a previous study in 2008 by Bense and 2010 by Basinman, where the interpretation is very straightforward. We had here west of the Chuchupa platform, the development of this clastic reservoir in the bottom, that you go a little bit up deep, you go into the Chuchupa field, and you have the low stand in the low stand here, maybe indicated here in yellow, the prograding units prograding to the west in yellow, and reflecting the low stand, and maybe the high stand in not so strongly prograding, but aggrading in the high stand position in the Pliocene. Still, you identify the break. The sequence stratigraphic concepts indicate that we might have development of good reservoirs, and this needs to be further studied in the area. We have another traps that have been identified more in the sense of structural traps related to the strike slip faulting, in particular in this part of the basin.
Creo porque acá no me aparece la función.
Hello?
Continue, Victor, please. It's just a technical.
Pues que los tengo muteados.
In this area. Hello?
Continue, Victor, please.
Okay. In this area, especially surrounding the Sierra Nevada de Santa Marta, we have the Oca strike slip fault, the Santa Marta Bucaramanga strike slip fault, and a little bit north, we have the Cuisa fault. In these areas, we have the presence of flower structure and pull-apart basins that in their sides, they have rotated blocks that might represent very interesting trapeze features related to this strike slip or rain tectonics. Here is an image coming south from the Campo Chuchupa to Almeja Well. Here in the middle, for those who might know this area, here we some years ago, the Volusco well was drilled on top of this pull-apart basin related to the Cuisa fault. And very interestingly, this Cuisa fault system might connect might represent the conduit to deeper portion of the basins where the silt rock can be matured. And this is a concept that has been published before by Claypool in the 80s and has been brought again in the picture by Benz in 2008 in order to explain, maybe explaining the presence of thermogenic hydrocarbons in Chuchupa gas field coming from the deeper portion of the area that has been connected by the pull-apart basin associated to the Cuisa fault. And some other features have been studied in this area by Galindo and other authors here in the Arasa and Bahia basin. Some additional plays have been also identified in the regional study. We have fractured basement, a reservoir that has been supposedly or interpreted that to be happening in the Riohacha field. If you read the files of the Riohacha field, it's a good proposal, but it's a good hypothesis, but it's not proven by the production. But regionally in the northwest of Venezuela, the fractured basement and reservoir has been recognized in Mara and La Paz field. We have very common on top of this basement of the sandstone overlapping the basement heights. In the upper or overlying sequence, we had these differential compaction closures, anticlines overlapping these basement heights, overlying these basement heights. In some extensional settings like the Guajira Rift that is behind the South Caribbean, the Forbel, you have anticlines in extensional settings that might be related to mud diapirs or internal faulting features. Especially in the Guajira, in the Colombia Basin, we have the extensive development or mass transport complexes that in a case we have identified in the Columbia Basin are really shallow, maybe Pliocene to Pleistocene, that might represent not necessarily a feature as reservoir, but a feature as regional silt for the petroleum system that might be underneath for in our case, for these fans or the reservoirs coming from the distal part of the Magdalena River. And in some parts of the Guajira Basin, we had identified this gravitational rotational features that might produce this elastic faulting that might conduct to the formation of very interesting structural closures. All these plays on top of the 11 I just described in detail, and these extra five I am describing here in summary are totally documented in the report with examples, with the geographic distribution, and further seismic images in order to illustrate what we believe is happening in the subsurface. This document, Daniel will clarify on this, but it should be already available for distribution. And on top of this identification of 16 plays regionally covered through the basin, we perform a petroleum system modeling, putting together all the evidences. This is the petroleum system model. I will give some examples. This is a full chapter in the report, and extracting just a couple of slides there. The Cretaceous materiality model that was just the same as the regional interpretation is the first time we put together a regional petroleum system modeling, including the Columbia Basin, the Sinú area, and the Guajira offshore areas. Here we have the depiction of the maturity model for the Cretaceous interpreted in the area. The model has an input from all the structural maps we prepare in the project. The experts Zamora performed several 1D modeling pseudo wells all around the basin. The thickness and rock quality were taken from ODP and these DP wells and some controls in the outcrops. I have to say that we were conservative, more conservative than Carvajal in putting together our model, but even being conservative, we had this very interesting result that in this, you might see this, called this light green, is the area where we have the main maturity level or the maturity window, the early maturity window for the Cretaceous rock, which covers an extensive area of the basin. And again, you remember, if you put together here the Delta fan, the distal Magdalena fan reservoirs, we might have a very interesting petroleum system situation there. The maturity was a model and the boreal was model, and the result for the Cretaceous is this one. And another example, the petroleum system modeling, again, a regional system modeling for the whole Caribbean, is the Oligocene charge model, where we see that in this scale, low, mid, and high probability of charge for the Oligocene to lower Miocene plays or possible reservoirs. We have the distribution, and very interestingly, the model predicts short and long distance migration patterns. Some of the migration patterns are vertical, of course, because especially in the Guajira, in the Columbia Basin, we see this vertical feature that might be faults or maybe gas chimneys, but are indicative of migration paths. And regionally, the models also very interestingly predict more occurrences of oil than gas. Of course, the province has discoveries of gas, like here in the southern in the Saudi Kronos, Gorgon, and Purple Angel, and here in the area like Orca. But maybe we are in a PVT condition and we haven't identified the proper fluids in the system that they might be studied further with more information. And putting together the structural interpretation, the play concepts, and the petroleum system modeling, we finally come into the proposal of play favorite maps for the regional area. This is the approach we use in this project. We put it together structural maps, paleogeographic maps, which are included in the report. I haven't included example of these ones here in detail, but are already in the report. The results of the petroleum system models and the identified place, compiling our place and place from before, and we produce a favorite map that is kind of a traffic light map, probability map, red indicating lower probability, yellow indicating fair probability, and green indicating high probability of occurrence of the particular place in the area. Putting together the flavor maps that are associated or that might be fed or might be related to Cretaceous rock, we have this distribution of the place. These are here we put together the place, the regional distribution of the place we have identified. Again, this is in the report, and we combine this in the geographic system software, the areal distribution of the structural map, the paleogeographic map indicating, of course, paleoenvironment and presence of particular type of rocks like shale and reservoir, the result of the petroleum system modeling, and this is a proposal, a high-level proposal of distribution on this particular place related to the Cretaceous. So that indicates that if you are looking for place related to the Cretaceous, the red area indicates that the presence is very unlikely. In yellow, the presence is maybe fair to good, and we have a good chance to finding this place associated to the Cretaceous in the green areas. The same exercise we did for the place associated to Oligocene, to early Miocene clastic and calcareous reservoir rocks. These units from the upper part of the Oligocene to early Miocene. We have overlap here the regional distribution of this place. And the same exercise, we combine in geographical terms this distribution with the petroleum system model, that in structural interpretation and the paleogeography, and we have a display favorite map again in the sense of probability. And in green, we see the areas where we might have the chance to have a good chances of finding these reservoirs, this place. And for the upper part of the sequence, the mid-Miocene to Pliocene clastic reservoir relative class to these clastic units, which of course imply that will have more implications for a stratigraphic place. We have the same exercise, and we have this broader distribution of this place. That these three favorite maps that I just presented indicate that in the area we have good probabilities of keep finding interesting accumulation. And remember, along with the petroleum system model, we have good probability of charge. And if we have in mind that we have extensive area of maturity for the Cretaceous rock, we have a really good prospectivity in the area. And finally, as main conclusions or reflections of this project, I will go through this. This is an extensive area, more than 200 to 250,000 square kilometers, has been considered a frontier province, but after the discoveries of the recent years, is already considered in the community as an emerging region, has a very high prospectivity in the level of close to 100 TCF. And at this time, 2 drilling operations are ongoing, and that will provide more information on the performance of the petroleum system in the area. We have identified 16 plate types. This can be combined, this can be split in a further fashion, but we have a good guidance here to keep looking at the features in the basin. Some events like the stratigraphic traps need to be studied in further detail with the use of 3D seismic. There are extensive 3D seismic programs in the basin that need to be deserve more studies, and we are going to pinpoint to to really identify the thermogenic processes. Further piston core or analytical campaigns need to use modern geochemical analysis like biomarkers and diamond dots. As a takeaway from this presentation, we put together works done in the past by the private companies, by the universities, but most of the works were done in a block by block or smaller areas, particular works. In this work, we presented the effort of putting this together in a single approach, in a synthetic approach, in a very straightforward identification of the place. This is already, of course, a tool to keep fostering and promoting the exploration in this area. And we use the place-based exploration as a methodology for putting together all the information that we have in the area. Of course, we need to keep working in further detail, more in the geochemistry, in the evidences we have of the petroleum systems, the extensive 3D seismic information needs to be used in further detail. And now I leave the audience for questions and something else or comments that I might have received. Thank you very much for your time. And Daniel will clarify the availability of this report. Thank you very much.
Thank you, Victor. Thank you for this amazing presentation and the big importance of integrate different knowledge produced by different entities, having the universities and the private companies. So as you mentioned, the video will be available next week. And as well, we are trying to upload the final reports of the different works that have been performed in the last year by the universities and the Geological Service of Colombia. So they will be soon into the web page as well to be available for everyone. So we got many questions in here, and all of them are quite interesting. So let's start. Álvaro Montoya is asking if you know from any well that was drilled by Texaco in front of Barranquilla and Cartagena at the beginning of the 70s.
Well, the wells Cartagena 1, Cartagena 2, I think Cartagena and Galera Samba were drilled by Texaco by the late 70s. In fact, I just read the report a few days ago. Cartagena 2 was drilled from November 1979 up to February 1980. This was the well that proved gas accumulation in the Cartagena area. The Cartagena 1 well was drilled in the same area, but has a how do you call that? It had a really big kick of mud, gas and mud, and almost sunk the boat. And they abandoned the Cartagena 1 and drilled the Cartagena 2. So the area was already known by Texaco. In that area, we revisited this area with the Equion and Ecopetrol and drilled the Mapale 1 well. So the accumulation is there, the knowledge is there. Maybe the market for gas wasn't good enough, or the size of the discovery wasn't good enough for further development. But I think Alvaro is referring to these words. Thank you.
Okay, Victor, there are 3 questions referring to the source rock. So I think for a matter of time, I will gather in the same question. So one person is asking if that looks that there are good reservoirs, but what about the source rock? We really need to understand that much better. And there's a second one that what would be the age of the source rock? And a third question about the source rock that by Alejandro Mora. Good morning. For the basin modeling, you're assuming that there are Cretaceous rocks, source rocks all over the area. Do you have Cretaceous thickness and source rock map quality maps?
Well, for the source rock, we might have 2 scenarios, and I have been careful on not to oversell the chances of the presence of Cretaceous. The ages we have from the DSDP and ODP wells are from Santonian to Campanian, and we go into the Columbia Basin. These are condensed sequence. We go deeper in the deeper portion of the basin, what I call hemigravens. We might have thicker sequences. We don't think, as Carvajal published, that the Cretaceous is all over. We think the Cretaceous is restricted in some of the hemigravens, even though the hemigravens are 40 to 60 kilometers wide, so still is extensive. For the model, I was very careful with Cesar Mora to be conservative with the modeling. The model used thicknesses of the level of 200 feet of rock. So we are not thinking in a source, in a mass balance, in a very big mass balance. We were very conservative, 200 feet. We took information from the DSDP, ODP wells, from all the locations in the shallower part, in the onshore areas, hydrogen indexes of 400 milligrams, TOC in the level of 4%. So we were really conservative, and still, it's also part of the report. I didn't present that here, but we have the numbers for the transformation ratio and amount of hydrocarbon generated. And if still being conservative, these numbers are very interesting. And I think there was a third one. I missed the third question.
The third question by Alejandro Mora is, if for the basin modeling that you're assuming a Cretaceous source rock all over the area, do you have Cretaceous thickness and source rock quality maps?
The Cretaceous, of course, we have a structural maps where we propose a Cretaceous. I don't have the number with me, but the numbers are available in the report. I understand that report can be, I mean, this information can be published, and if Alejandro drop me an email, I will give him the numbers. But we are conservative. We're not exceeding what we think. And also on top of the ideas of Cretaceous subrock, we must have subrock, because we have discoveries. We have gas accumulations in Chuchupa, Ballena, Orca, Kronos, Gorgon, Purple Angel. And of course, we might think that the biogenic process are more outstanding, but several evidences from these discoveries indicate that there is at least a minor contribution of thermogenics that might come from somewhere. And piston core, like we are evaluating that at this time, 50 to 70% of the piston cores in the area show thermogenic evidences that might come from Eocene or Oligocene subrock that should be present in the deeper portion of the area. So we might have Cretaceous, Eocene, and Oligocene subrock in the area. And for the biogenic, whenever you have a subrock, even immature, like the middle to upper Miocene, of course we'll have another subrock. Not as good, but enough for the biogenic occurrences.
Okay, Victor, thank you. There's an interesting question by Diego Nicolas Lafa. He said, good work. For the maturity model, are you considering the Magdalena sediments interaction as an effect of overburden, or do you consider as well a thermogenic source from the basement?
Okay, I will think that Diego Yafa is referring to radiogenic heat. In fact, we were discussing this last night and today with Cesar Mora. Of course, the model implies that we had to put an overburden, maybe hydrated sediments, very aqueous sediments that will have an implication on the overburden and the thermal regime. And in the area where we find the biggest deposit center in the Columbia Basin. It's the same area that recent works by Garcia and presented by Ion some weeks ago. It's the same area where they claim that the crust is really thin. And we are already thinking if this implies that we have higher heat flow in the area that might contribute to the maturation. We are considering this. We run some models and we consider that, but even if it's thin, it's a thin crust, it's still a oceanic crust, which will have we supposedly have a lower radiogenic contribution, but if the crust is thin, we might have contribution from the mantle. I mean, thermal contribution. Something we need to consider, and some of the work we are already thinking in pursuing. Thank you. Thank you, Diego.
Okay, next question is by Gloria Obando. In the tectonic and structural complexity of the South Caribbean, how do we approach with certainty with the place presented in terms of the maturity, of the conditions of maturity?
Well, the places identified, most of them, I have to recognize, most of them are based on 2D seismics. In some of them we managed to use 3D seismics, so the places are present there. So the geometry is identified. The structural features are easily identified. In terms of maturity, we have a mid to low thermal regime. We have area of 35 to 40 milliwatts per square meter. So we are conservative there, but the places are present. Of course, this is a play proposal. You go into every play, you need to go into further detail to have lead and prospects, and then you will need geomechanical and boreal specific models. But I think we have, broadly speaking, good possibilities of the maturity level of the petroleum systems. But what is happening now that even if we have a conservative or low thermal regime, we already have gas presence in the area. The problem with the gas won't be technical but commercial. That we might keep going, we might keep finding gas, and we will put this interesting problem on the shoulders of the commercial people. But for the technical side, the presence of gas is already there. Thank you, Gloria.
Okay, Victor, thank you for the answer. So there's another question by Gloria. She's asking about what's the maximum depth, what's the deepest that a well has reached into the basin?
Well, I think the deepest well is Calazú. It's a deep wells in terms of operation. It's in the level of 6,000 meters. So it's close to 20,000 feet, but it's as you saw in the images, it's in the South Caribbean, the Fort Belt, in terms of operational depth. And if you go into further in the far area of the basin, which is the Columbia Basin, the wells are in deep water, 3,000 meters of water depth, but they didn't drill a thick column. They drilled less than, as I remember, I will say less than 500 or 400 meters, because they are in the higher position in the Embera Ridge and the Beata Ridge, and they didn't drill a thick stratigraphic column. Remember, this should be condensation. So we will need a well in the deeper portion of the area. You go in front of the South Caribbean, the Fort Belt, outboard of the Guajira Basin, you may have a thickness depth of the sedimentary sequence of the level of 10,000 meters, 30,000 more than 50,000 feet of sedimentary sequence, but this is from the structural mapping, no from the wells. Thank you.
Okay, thank you, Victor. Let's see. There's a question by Lucia Torrado. She's wondering, how did you build the thermal maturity model? For example, for the pseudo wells, which constraints did you use?
Well, the constraints we have, of course, pseudo wells, you have to assume some things. We have structural maps that give us a good idea of the thicknesses we have. The thermal regime, remember that many of the piston core locations also include heat flow measurements. So we have these heat flow measurements. And in the model, we have to, in the models, usual inputs for the models are paleobathymetry concepts, and where we have wells, which are not few locations, we have the calibrations of thermal maturity that has been measured. But in the pseudo wells, you have to make some assumptions, especially you go in area like in the area we were just mentioning, that to be the deep depot center, we have to take especially thermal heat flow data from the piston coring. Thank you, Lucia.
Okay, Victor. So next question is by Marcio Melo. There are any biomarkers or diamantoid data from the heavy oils that you have mentioned? If so, what was the conclusions?
Hello, Marcio. These wells that I mentioned, Chimare and Santa Ana, these are wells from the 90s, from the 70s, 78, 79. The report claims that they found residual heavy oil. We are trying to track this on the rock depository. If we find them, we might perform this analysis, but at this time we don't have this information. The biomarkers and the amondoids we have in the basin are from the piston core campaigns from Ecopetrol in 2009 and Ekion in 2012. And unfortunately, all the other piston core campaigns have been just restricted to the regular basic geochemical techniques, and something we need to recommend to the authorities to try to be more efficient in getting more information from the piston coring. Thank you, Marcio.
Okay, Victor, thank you very much. There's an interesting question by Diego Venegas. He says, firstly, that very good presentation, Victor. How do the interpreters manage the region between the oceanic crust and the continental crust?
Well, this is interpretation, of course. We have wells in the, again, we have an extensive area in the middle of the study area where no well control. We have ODP and BSDP in the further north and northwest part of the area, where we have they are described as basalts, ultramafic rocks, serpentinites, and we go into the near shore. We have wells in the Guajira and the Sinu area that have drilled some of them have drilled the basement and claim that have more granitic affinity. And from the interpretation, we believe that we go close, when you go from east to west to the South Caribbean, the Fort Bell, we might have a backstop or a wedge where the continental crust is starting to be like a transitional or mixed crust, and you go out of the South Caribbean, the Fort Bell to the Caribbean basin. It should be already oceanic crust. The recent models that have been published that have been presented in the work by Ion, these are from Garcia and I don't remember the other authors, recent authors. They claim or they see features that are typical from oceanic crust. The sea deepening reflectors, the internal features, and even they claim that the seismic image might be interpreted as the in some of them you can interpret the moho boundary. So these are from the seismic interpretation, but of course these are more interpretation than direct data. Thank you, Diego.
Thank you, Victor, for that answer. And I think this is the last one. Hi, Victor, by Martin Reyes Correa. Hi, Victor, thanks for the talk. In terms of your play fairway map analysis, which was the most critical input and why? Did you give the same values for all of your maps?
Well, I don't know if I don't want to say critical, but you have to assign some uncertainties. We have structural maps. We have the petroleum system model that has some inputs, and I have to say again, we were conservative. We don't want to overshot on these things, and maybe what we propose as the regional distribution of the play might deserve further detail. I showed you some polygons that represent the regional distribution of the play, but this is based on mainly into the seismic, mainly related to the identification of the structural feature. And for instance, if you see the fault belt plays, you can follow them because are one-to-one associated to the South Caribbean, the fault belt. But for the carbonates on basement highs, you might have some uncertainty because you don't know in all the basement highs you have the carbonate development. So there are some uncertainties there. That's why in a more detailed project we should make extensive use of 3D seismic because it's available, and that will lower the uncertainty of the geographic distribution of the place. Maybe allow us to go into further detail, identify further place, or maybe lump together some of the place that we identify. Thank you, Martin.
Okay, Victor, it seems that we don't have any more questions. So from the ENH, we'd like to thank you for this really nice presentation as a summary of the different approaches that have been carried out into the Caribbean and your great knowledge about the area. Thank you for all of the attendees for being here today. We'll be waiting for you next Friday into the ENH to talk about the seismic programs that have been acquired. Thank you, Victor.
Thank you. Thank you all. Take care. See you next time in one of these interesting talks.
Thank you.